Okay, so let us see the solution of Nielit Scientist B 2016 question paper. So in the question paper there were the two parts, one was general aptitude, another was technical part. So we are starting with technical part first, and the technical part was starting from question number 61. So the question number 61 is which one of the following is digital to analog conversion technique? And this question is from digital electronics, and in digital electronics we study few types of DAC and few types of ADC. So types of DAC we study is number 1, this is R to R ladder type DAC, and second we study weighted resistor type DAC. So second is weighted resistor type DAC, and the type of ADC we study, number 1 is flash type ADC, first is which is fastest ADC, so flash type ADC. Second is SAR successive approximation resistor type ADC, so SAR type ADC. Third is single slope type ADC, or we call it counter type ADC, and another name of it is ramp type ADC. Fourth one we have is dual slope ADC. So these are the few types of DAC and these are few types of ADC. Let us see in the options what we are given. So which one of the following is digital to analog conversion technique? So SAR approximation is DAC, no, it is ADC. Weighted resistor, yes, this is DAC, and dual slope is ADC, and single slope is also ADC. So correct option, we are asked about DAC, so correct option will be B. So next question is question number 62. So in the question number 62, we are given the input output relationship of causal stable LTI system. So we are given, this is question number 62, we are given LTI system which is causal. So we are given causal LTI system, and input output relationship we are given. So output yn is related with input as alpha times y of n minus 1 plus beta times x of n. And if the impulse response Hn of the system satisfy the condition summation n equals to 0 to infinity Hn is 2, then the relationship between alpha and beta. Okay, so from this let us find out Hn. So we will take the Z transform. So H of Z is going to be alpha Z inverse y of Z plus beta times x of Z. So if we take yz common, then we will get 1 minus alpha of Z inverse equals to beta times x of Z. So from this yz yxz we can find that is beta upon 1 minus alpha Z inverse. So this is yz yxz, right? So this is what xhz, okay, and we are given that summation n equals to 0 to infinity h of n is 2, okay, and in the question we are given that system is causal. It means that Hn is 0 for all n less than 0. This is a right sided signal. The causal means in the left side Hn is 0, it is only right sided signal. So we know the formula for finding out Z transform of this Hn, then we can find out that Hz equals to summation n equals to minus infinity to infinity Hn Z to the power minus n, right? So n we are putting minus infinity to infinity, but we know that Hn is existing from 0 to infinity only. For n less than 0, Hn is 0, because in the question we were given that this system is causal. So Hz we can write then summation n equals to 0 to infinity h of n Z to the power minus n, right? So if we put Z equals to 1 here, then what we will get? So putting Z equals to 1, then h of 1 we will get summation n equals to 0 to infinity. So this is Hn, and Z equals to 1 if we put, then 1 to the power minus n, it will be 1. So we got n equals to 0 to infinity Hn, and in the question which we were given was 2. So we found out that h1 is 2. So from this if we put Z equals to 1, in this putting Z equals to 1, then h of 1. So h of 1 if we put here, then we will get beta by 1 minus alpha. 1 inverse will be 1, so let's make it 1 only. So we got beta by 1 minus alpha, right? So h1 from this we are getting 2, so let's put equals to 2. So we got from this beta equals to 2 times 1 minus alpha. So this is the relation between alpha and beta. This is 1 minus alpha. So let us see the options. Beta equals to 2 times 1 minus alpha. So if we arrange this, then this is going to be beta by 2. So from this, if we write beta by 2 equals to 1 minus alpha, and alpha we can write 1 minus beta by 2. So this is matching with alpha equals to 1 minus beta by 2. This is matching with the option A. So the correct option of this question will be A. So let us go to the next question, question number 63. So question number 63 is again from signal and system. So we are given the unit impulse response of a system is ht. So unit impulse response ht we are given, that is e to the power minus t for all t greater than equals to 0. For this system, the steady state value of output for unit step input is. So this is the system we are given whose impulse response is ht, and let us say we are giving input xt, and if output we are taking yt, then we can write yt equals to xt convolution ht, right? And if we take a Laplace transform, then ys we can write x of s into h of s, right? So input is, we are given that for the system the steady state value of the output for unit step, right? So if xt is ut, so this xt is ut, then its impulse response we know it will be 1 by s, right? And ht is e to the power minus t, then hs will be 1 by s plus 1. So this is ys I got, and what we are asked in the question, steady state value of output. So we are asked to find out y of infinity, that is value of output at t equals to infinity, or steady state value of output. Then we can apply a final value theorem. So with final value theorem we can write y of infinity, that is limit t tending to infinity y of t, we can write limit s tending to 0 sy of s, right? And with Laplace transform we found ys. So from this we can write y of infinity, that is equals to limit s tending to 0 s into ys is 1 by s into s plus 1, right? So s is going to be cancelled out, s we put 0 here, then we will get 1. So the correct option of this question number 63 will be C. So answer is C. Now let us go to next question, that is question number 64. In the question number 64, this is from analog circuit, and the question is a transistor connected in a common base configuration. So we know common base configuration is like this. In common base we make, this is our base, we make base grounded, this is collector and this is emitter. Okay, so in common base we give input at emitter terminal and we take output from collector terminal. So if we look into this BJT from emitter terminal, then we can write resistance is, so Ri is going to be alpha by Gm plus Rb upon 1 plus beta. So if you are not given anything, then let's say Rb is 0, so this term will be 0, then Ri will got alpha by Gm. So alpha is a common base current gain which is generally equals to 1. So this Ri will be almost 1 by Gm, and this is 1 by Gm. So and R output, if we look at from collector terminal into this BJT, so R output we get infinity. So this is input impedance we found and output impedance. Now if you don't know how to write it, then I have already made a video on it. You can check out that video in top right corner. You can easily write resistance looking into any terminal of the BJT. So Ri is this, R output is infinity. Now let us see the options. So a transistor connected in common base configuration has high input resistance and low output resistance. No, output resistance is high. B is a low input resistance and high output resistance. So yes, output resistance is high. And is input resistance low? Yes, this is 1 by Gm, this is comparatively low. right? So correct option with this will be B. So now let us go to next question, that is question number 65. So question number 65 is from mathematics, and we are given the determinant of matrix A. So we have a matrix A whose determinant is 5, and the determinant of matrix B is 40, and we are asked the determinant of matrix of AB. So we know it's a property that determinant of AB is, we can write determinant A into determinant of B. So this is 5 into 40, this is going to be 200. So correct option is D. So let's go to next question is 66. So let's go to question number 66, and this is from control system, and the question is a unity feedback control system has open loop transfer function. So question number 66, we are given open loop transfer function and unity feedback. So GS is 4 into 1 plus 2s divided by s square into s plus 2. Okay, if the input to the system is a unit ramp, so RT is unit ramp, or XT we can say, the input is RT. So input we are given unit ramp, then R of S we can write this is 1 by s square, right? Now the steady state error will be, so steady state error for ramp input, steady state error for ramp input we can write 1 by Ka, right? Or so steady state error for so steady state error for ramp input we can write 1 by Kv, where Kv is velocity error coefficient, right? And Kv we write limit and Kv we write Kv equals to limit s tending to 0 s g of s, right? So let us find out Kv, then this is going to be limit of s tending to 0, s into gs is 4 1 plus 2s divided by s square into s plus 2. So ss will cancel out, and if you put s equals to 0 here, then Kv you will get 1 by 0 equals to infinity. Now let us find out ESS, this is going to be 1 by infinity equals to 0. So steady state error is going to be 0. So this is the method you can find out ESS, but the shortcut is, so shortcut you could see type of the system. So type of the system, 2 poles at origin, so type of the system is 2, and type of the input is ramp, type of the input is 1. So if type of system is greater than type of input, so this is system, this is input. If type of system is greater than type of input, then we can directly conclude steady state error is 0. If type of system is type of input, then steady state error will come out some constant. If type of system is less than type of input, then you could directly conclude steady state error is infinity. So this is the shortcut, you could easily answer this question with this. Okay, now let us go to next question. So next question we will go to question number 68. So question number 68 is, which one of the following condition will not guarantee a distortion-less transmission line? So for distortion-less transmission line, so for distortion-less transmission line, the condition is Lg equals to Rc, and we have to see which of this condition will not guarantee distortion-less transmission line. So if R is 0, G is 0. So if R is 0, this is made 0 and G is made 0. So LHF is RHS. So yes, this condition will be satisfied. So in this case condition satisfied. Lg equals to Rc, yes, in this case condition is satisfied. In the C option is R much greater than omega L and G is much greater than omega C. So let's observe this, R much greater than omega L and G much greater than omega C. It means that the frequency is very low. It means that this condition is at low frequencies. Okay, so in transmission line these R and G tells the losses, right? And we know that every lossless transmission line is distortionless, right? We know that every lossless transmission line is distortionless. So here losses are much, right? So at low frequencies we have much losses and this is not lossless. So this condition cannot say transmission line is distortionless, right? D condition is R much less than omega L and G much less than omega C. So this condition is high frequencies, right? And we are saying R and G will be much less than this omega L and omega C. It means that there are very less losses. So we can say this is lossless, and every lossless transmission line is distortionless. So in D case also it can guarantee or it can say that transmission line is lossless, but in C case we cannot say that transmission line will be distortionless. So correct option with this we will have C. So let us go to next question, question number 70. So question number 70 is the logic function implemented by the circuit given below is. So we have to find out logic function which is implemented by this circuit. So we have 4:1 mux and this is 0. So this is going to be 0. So this is 1, again this is 0, right? Because this is inverter. So this is 1, this is 1. So for I1 and I2 input only we will get output. So let us find out for question number 70. So let us write the output. F is going to be then, so this is S1 S0 S1 bar F0 bar. So S1 bar S0, that is 0 1 will get 1 plus S1 S0 bar, again we will get 1 1. So this is XOR gate. So S1 XOR S0. So output we will get XOR, or inputs are PQ, these are PQ, S1 S0 are PQ. So we will get P XOR Q. So F is P XOR Q, then correct option will be D. Okay, so question number 70, correct option we will have is D. So correct option will be D. Now let us go to next questions. So now let us go to next questions. Question number 71. In the given circuit, the value of V1 and V2 respectively are. So question is from network, and the question 71 is we have to find out value of V1 and V2, right? So this is the voltage V1 here. Let's apply KCL at this node A. So writing KCL. So KCL will be outgoing current is I. So let us write incoming current is 5 equals to outgoing current will be I plus V1 by 4 plus this is going to be 2I, right? So 5 equals to 3I plus V1 by 4. So this is equation 1, and we can write this V1, this is I current is going this 4 ohm and voltage across this 4 ohm is V1. So V1 we can write 4I, right? So 4I. So V1 by 4 we can write I. So V1 by 4, if we put I here, then 5 equals to 3I plus I. 5 equals to 4I, and I we will get 5 by 4. Okay, so let's plug this I here. So you will get V1 equals to 4 into I is 5 by 4. 4 will cancel out. So V1 you will get 5. Okay, so V1 you will get 5. Now how you can write V2? So to write V2, you know 5 ampere current is coming here. So you can write 5 ampere incoming current equals to V2 minus V1 by 4. Okay, so this is going to be 20 plus V1 equals to V2, and V1 you found 5. So V2 you will get 25 from here. So V1 is 5, V2 is 25, then correct option will be A. So let us go to question number 72. The Z transform of the function given below. So we have to find out its Z transform. So function we are given k equals to 0 to infinity del of n minus k, right? So if you keep on putting, this is question number 72. So if you keep on putting k equals to 0 1 2, then we will get del n plus del of n minus 1 plus del of n minus 2 plus dot dot dot. Let's take Z transform now, and we know del n Z transform is 1. Del n minus 1 will be Z inverse plus Z minus 2 plus dot 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 we will get, and this will come GP, right? So let us solve it. We know for GB 1 upon 1 minus r, and r will be z inverse, so 1 upon 1 minus z inverse. So we will get z upon z minus 1. So if we call this sequence xn, then z transform xz, we got z upon z minus 1. So correct option will be B. So this is one of the ways, and another way was you could easily solve this question, because you know this impulse is getting summed, and this will be, if you put k equals to 0 direct, then you could write it un. Okay, so if you put k equals to 0 direct, you could write it un, and un follow z transform of un is z upon z minus 1. Let us go to the next question, question number 73. The transfer function Cs by Rs in the block diagram shown below is, so we have to find out Cs by Rs. So we can easily solve this. This is R coming, and R will be also coming here, and R is coming here, right? So G1 will be multiplied in this, so this is going to be R G1, okay, and then R will be added, right? So this is R G1 plus R, and G2 is multiplied, so here it will come G2, so we will add again R, then this is going to be R G1 plus R into G2 plus R, okay, then we will get C. So if you take R common, then you are taking R common, then this will be G1 G2 plus G2 plus 1 equals to C. So C by R you can easily write 1 plus G2 plus G1 G2, okay. So 1 plus G2 plus G1 G2, so correct option will be C. Now let us go to next question number 74. If sequence xn is from minus 5 to 3 and hn is 2 to 6, and if these two sequences are convolved, then the duration of resultant sequence will be. So we know if xn is n minus 5 to 3 and hn is n, this is 2 to 6, then yn, if we are calculating, that is xn convolution hn, then yn will be existing from minus 5 plus 2 minus 3 to 6 plus 3 9, simply just adding extreme points, okay. So this will be existing from minus 3 to 9, so correct option will be B. So let's go to our next question number 75, okay. So the question number 75 is from signal and system, and the question is a signal xt has Fourier transform x of omega, okay. So this is question number 75. So we are given xt has Fourier transform x of omega, okay, and if xt is real and odd, so we know that this is xt and its Fourier transform is omega, okay. If xt is real plus even, then x omega will be real plus even, right. If this is real plus odd, this will be, okay. So if real plus odd, this will be imaginary plus odd. If this is imaginary plus even, then x omega will be imaginary plus even, and if this is imaginary plus odd, then this will be real plus odd, okay. So in the question we are given xt is real and odd, okay. If this is real and odd, then x omega will be imaginary plus odd, so correct option will be B. So let's go to question number 76. The 4-point discrete Fourier transform DFT of a discrete time sequence xn. So xn discrete time sequence we are given 1 0 2 and 3, right, and we can observe this is a real sequence. If this is real, then we know xn conjugate will be xn only. Then if we take its DFT, then x of minus k conjugate will be x of k, and this is periodic with n, so we can write x of n minus k conjugate will be x of k, and we know that we write x of k equals to summation of n equals to 0 to n minus 1, this is xn e to the power minus j 2 pi by n kn, okay. So if we put x equals to 0, so x0 is going to be summation n equals to 0 to n minus 1. So if we add all the elements, then we will get x of 0. So x of 0 will be, you add these 3 to 5 0 6, so x0 will be 6. So B, A and B cannot be the option, only C and D will be correct. So if you put here n equals to 1, or if you put here k equals to 1, then x of 4 minus 1 conjugate is going to be x of 1. So x of 3 conjugate is going to be x of 1. So first and third element are going to be conjugate each other. So first and third element, yes, but also we know that x of 0 plus x of n by 2 equals to 2 times, so x of 0 plus x of 2. Okay, so 2 times x of 0 is what, 1, and x of 2 element is 0 1 2, this is 2, so 2 and this is 3, 3 2 is 6, and this is x of 0 is 6 plus x of n by 2 means x of 2, so this will be cancelled out and x of 2 will be 0. So option in x2 is 0 is D, so correct option will be D. So this is how with these properties you can solve these questions easily. Now let us go to next question. So question is 77. So the 77 question is from signal and system from Z transform topic. So the question is, for the discrete time system shown in the figure below, the poles of system transfer function are located at. So we have to find out the location of poles of the system, right? So let us find out Hz first. That is, we have to find out Hz equals to yz by xz, and from that we can see poles where these poles are located. So for that this is yn, so this is if you take Z transform, this will be y of z, and this will be z inverse y of z, okay, and this will be z minus 2 y of z. Okay, now let us write it. So x of z plus minus 1 by 6 z minus 2 y of z. So here we came, in this also we will add z inverse into 5 by 6, z inverse y of z into 5 by 6, this will be equals to y of z, right. So x of z will be, let's take yz common and we can write 1 plus not minus 1 by 6 z inverse plus 1 by 6 z minus 2. Okay, so from this we write yz by xz, this is going to be 1 by this is 6 minus 5 z inverse plus z minus 2 by 6. Okay, so if we multiply z square in numerator and denominator, we will find 6z square by, this is 6z square minus 5z plus 1. Okay, so let's factorize this one. So this will be 6z square by, in denominator we can write 6z square minus 3z minus 2z plus 1. Okay, so 6z square by 3z, if we take common, this is going to be 2z minus 1, and minus 1 if we take common, this will be 2z minus 1. So 6z square by 2z minus 1 and 3z minus 1. Okay, so poles will be, if you put 2z minus 1 equals to 0, so from this you can find out poles are going to be z equals to 1 by 2 and 1 by 3. So poles are at z equals to 1 by 2 and 1 by 3, then correct option will be C, where poles are at 1 by 2 and 1 by 3. So let's go to next. So question is 78. So question number 78 is, first 6 points of 8 point DFT. So number of points are 8 of a real valued sequence. So we are given the sequence is real. So we can apply the property x of n minus k conjugate equals to x of k. Okay, so we are given first 6 points of 8 point DFT of a real valued sequence are 5. So x of k we write 5, then 1 minus j3, then 0, then 3 minus j4, then 0, then 3 plus j4, and this is 0 1 2 3 4 5, this is going to be x of 6, x of 7. So this is x of 7. Okay, so we know x of n is 8, so 8 minus k conjugate is going to be x of k, right. So if you put k equals to 7, then this is going to be x of 7 equals to 8 minus 7 is 1, so x of 1 conjugate. So x of 7, x1, this 0 1, this is x of 1, so its conjugate is going to be 1 plus j3. So x of 7, from here we can find out this is 1 plus j3, and x of 6, we put k equals to 6, then x of 6 will be x of 8 minus 6 is 2, so x of 2 conjugate, right? So this is 0 1 2, this is going to be 0. So correct option with this we will have is 0 1 plus j3, so this will be B. Now let's go to next question. The question is 79. This is from communication system, and the question is a signal xt equals to 2 cos. So signal we are given, this is 2 cos pi 10 to the power 4t. So this is a signal in volt is applied to an FM modulator. Okay, this is from FM with the sensitivity constant of 10 kilohertz per volt. So kf we are given 10 kilohertz per volt. So this unit is hertz per volt. Then we can write FIT, that is instantaneous frequency, equals to FC plus KFMT. Okay, so we are asked the modulation index of FM is, we know a modulation index of FM is delta F maximum divided by F maximum. Okay, so from this if we write, this is pi into this is omega m equals to pi into 10k. So Fm you can find from this, this will be 5k. Okay, and now we have to find out delta F maximum. Okay, so from this frequency deviation, if you write FIT minus FC, this is nothing but delta F. So this is going to be KF MT, and we have to find out delta F maximum. So this will be KF mod of MT maximum, right? So MT is, this is MT, XT is nothing but MT. So 2 cos pi into 10 to the power 4t. So if you take its mod and you find out its maximum value, this is going to be 2. So from this you can write 2 kf, and kf is how much? Kf we are given is 10k. So this is going to be 2 into 10, 20k. So delta F maximum you found 20k. So if you put here, then this is 20k by Fm is 5k. So this is 5k. So 5 4 20. So beta, that is modulation index for this FM, is going to be 4. So correct option we will have is A. So let's go to next question. Question is 80. So question is this is the theoretical question from communication system, super heterodyne receiver topic. So the question is the image channel selectivity of super heterodyne receiver depends upon. So we know in super heterodyne receiver we have a pre-selector, then we have RF amplifier block, and we have IF amplifier. So to remove the image signal or to select the image signal, we can remove it before this IF amplifier. Once the signal is got to IF amplifier, then we cannot remove. So these two blocks can remove the image signal. If these two blocks did not remove image signal, after that once it reached to IF amplifier, then this signal cannot be removed. So we can say image channel selectivity of super heterodyne receiver depends upon pre-selector and RF amplifier. So this is just the theoretical question from super heterodyne receiver topic. So let's go to next question number 81. So question number 81 is a wave is incident normally on a good conductor. Okay, if the frequency of a plane electromagnetic wave increases 4 times. So if F1 was F and F2 increased 4 times, this is 4F, then the skin depth will be, so we know for a conductor the skin depth is 1 upon under root pi F mu sigma. So skin depth is proportional to 1 by root F, right? So skin depth delta 2 by delta 1 we can write root F1 by F2. Okay, so F1 is F, F2 is increased 4 times, this is 4F. So F cancel out, we will get 1 by 2. So delta 2 will be delta 1 by 2. So this will be decreased by factor of 2. So correct option will be D.